Hi and welcome to another explainer. This explainer is going to go through the different atomic models that we've had, looking at how we came about those models, what they actually were, and how we moved on in terms of our understanding. So we're going to look at our 5 scientists who were involved in this. We've got Dalton, Thomson, Rutherford, Bohr, and Chadwick. So let's start really quickly with Dalton's atomic model. So he said that atoms were hard, solid spheres. So as you can see from that picture there, he said that each sphere was a different mass and size depending on which element it was. He said that each element was unique, which is obviously what we understand it to be now, and that each of those elements had a different mass and different size and different reactivities and properties based on those sizes as well. So if we move on from Dalton's model, we can look at Thompson's model. So Thompson's model came about because of experiments that we'd done with cathode ray tubes, where using electricity, we discovered the electron. And so what happened here is, instead of being that hard solid sphere, we discovered this structure. And Thompson's model was that he had a positive sphere with negative electrons dotted about. And he called it the plum pudding model. Now, back in the 1800s when this came about, people ate plum pudding as regular puddings for their teas and stuff like that. We don't do that anymore. So I like to explain it a little bit like a chocolate chip cookie. So if you have your cookie dough and you have your chocolate chips dotted about in it, the cookie dough would be the positive sphere and your electrons would be the chocolate chips, just to give it something of a little bit of a more modern turn so you guys can understand it. Obviously, as technology got better and we performed more and more experiments, we discovered that Thompson's model was in fact incorrect. And the scientist who discovered this was Rutherford. And Rutherford came up with what he called his nuclear model. And what happened was Rutherford and some scientists who worked for him performed the gold foil experiment. Now, this is also known as the alpha scattering experiment. And what happened was they took an alpha source and they fired it at a piece of thin gold foil. And the beam of alpha particles were expected to go straight through. What they found was that some deflected and changed direction, some bounced back, but most passed straight through without changing direction. And so from these results, Rutherford came up with his nuclear model. And what he said was that there was a dense, positively charged nucleus with electrons orbiting the nucleus. Now we got to this because of this part right here, the fact that most passed straight through. And what he said was that he thought the atom was mostly space. And so he built his model to have that. So as you can see from the model, we've got lots of space all in around here. So that must have been where the alpha particles were passing through. They weren't close enough to the positive charge in the middle to actually be deflected or bounced back, and they passed straight through that space. So that was what our model became, Rutherford's nuclear model, where it was a positive charge in the center of the nucleus and negative electrons orbiting it with lots of space around it. As people did more and more experiments, we discovered more things about this model. And this is where Bohr and Chadwick came in. So Bohr discovered that electrons orbited the nucleus in set distances based on their energy. And so what he came up with was almost like a solar system model, where we have rings of electrons orbiting our nucleus. That's where our energy shells or electron shells or energy levels, as different people call them, came from. So we've got each of our electrons on a different shell, a set distance away from the nucleus based on the energy that they had. As we discovered more things, we realized that actually what the nucleus had inside of it wasn't quite correct. Bohr's model still only had protons in there. And there was a mass missing. The protons themselves couldn't account for the actual mass of each of the atoms. There was something missing. This is where Chadwick comes in, because Chadwick discovered the neutron. And the neutron explained the missing mass. So our neutrons have no charge. They don't play a part in any of the reactions or reactivity properties of our atoms. And so we hadn't been able to discover them up until this point. And we knew that there was extra mass in the nucleus. So when Chadwick discovered the neutron, we put this extra mass into the nucleus, and it explained the mass difference that we had. So these were our models of the atom. We've got Daltons, hard solid spheres, Thompson's plum pudding model with a positive sphere with negative electrons dotted about, Rutherford's nuclear model where we had a positive charge in the nucleus in the center, electrons orbiting that positively charged nucleus with lots of space in the atom, and then that nuclear model was developed into the model that Bohr gave us, which is the one that we still use at GCSE now, where we have our electrons on energy levels set distances from our nucleus, with our nucleus now containing our neutron as discovered by Chadwick. Thank you for watching this video, guys. I will be back with you again with another explainer very soon.